This is our second problem dealing with expected monetary values. This is dealing with a decision matrix looking at slides 9 and 10. And the problem is about the Flying Goose Lodge. Before we start there, I want to take a look, though, at slide number 10. You have on this slide a multitude of information. You have consequences, you have alternatives, events of nature, and the consequences that can happen. So if we take a look at the number of cancellations here, we're actually taking a look at the events that can take place. Going down on your alternative strategies, those are the alternatives that you can do. Probabilities are written right here on what's a probability that the event will take place. And we have in here consequences that we're going to be taking a look at. And if you remember back from decision science, you labeled these boxes on a decision matrix by row, then column. So if our overbooking one room with 0 cancellation, this would be row 1, column 1. We're still in row 1 with overbooking 0 rooms with 1 cancellation, so that's row 1, column 2. 2 cancellations, row 1, column 3, row 1, column 4. Those are the consequences that we're looking at. I'm going to pick a column to go down to show you how that is labeled, and we're looking at number of cancellations being 2. So this is overbooking 1 room is row 2, in column 3. Overbooking 2 rooms is row 3, column 3, so it's consequence sub 3-3. And overbooking 3 rooms is consequence 4-3. So that's how we're going to be looking at how things are labeled within this slide. So let's go back up and take a look at the problem. The problem with the Flying Goose Lodge. The Flying Goose Ski Lodge is gearing up for midwinter school vacation week, which is traditionally one of the busiest and most profitable weeks of the ski season. The lodge's 40 rooms go for $80 per night, which is one of the least expensive lodges in the area. The lodge requires that guests cancel 48 hours prior to the reservation date in order to receive a full refund. However, it is often still difficult to fill those rooms at the last minute. Thus, Flying Goose sometimes overbooks. But if the lodge is filled when the overbooked guests show up, the Flying Goose must find accommodations at other inns or hotels for those guests at their own expense, at a cost of $140 per room or more. The probabilities of no-shows are shown in the decision matrix on the next slide. How many rooms should the Flying Goose overbook? So we're looking at information here. 40 rooms at $80 per night. If you need to outsource because you've overbooked, that costs you $140. So let's take a look and get some baseline agreement and assumptions made. Because I like to use smaller numbers, we're going to assume they want to completely book up. That means filling all of the rooms. So I'm going to zero us out if we're at complete or full capacity. That's what we want to be at. It will cost us $140 to outsource. And we're going to assume for the purpose of this problem that they are calling to cancel in time. Because if they don't cancel in time, they still have to pay you the $80. We want to assume that they have canceled in time. So using these assumptions, let's go to our decision matrix and let's take a look at this problem. We're looking at overbooking rooms and canceling. We can control the overbooking rooms, our alternative strategies. Cancellations, we really cannot control. So looking at the overbooking of rooms and whether or not we should do it, how much money are we going to be up or down? If full capacity, we're going to consider that zeroed out. Where are we going to be? So if we overbook 0 rooms, and we have 0 cancellations, we're not up any money or down any money. So that right there is going to be a 0. If we overbook 1 room and we have 1 cancellation, we can take that overbooked person and put them in that canceled room. So again, we're not losing any money, we're not gaining any money. That's a 0. If we overbook 2 rooms and we have 2 cancellations, we can take both of those rooms that we've overbooked and put them into the canceled rooms. So again, we are zeroing ourselves out. We're not making any extra money or losing any money. If we overbook 3 rooms and we have 3 cancellations, again, we can zero ourselves out because we can put each one of those overbookings into a canceled room. So there's our premise to begin with. Now let's go across the matrix and look at the consequences for overbooking 0 rooms. If we have 1, 2, or 3 cancellations. If we overbook 0 rooms and we have a cancellation, we end up with an empty room. That means we're losing money. And when we lose money for a room, we're out $80 because we just have 1 open room. Now you can put -80 there, you can put the 80 in the parentheses and do it accounting style. As long as you do it the same way throughout the whole matrix, that's okay. If we overbook 0 rooms and we have 2 cancellations, we now have 2 open rooms. By having 2 open rooms, we're losing the money, $80 for each room. So we are out $160. Overbooking 3 rooms, canceling 3 cancellations and overbooking 0 rooms. Again, $80 per room. We are going to be losing money, and that's going to be $240 or 80 times 3. Do you see how we're filling out this matrix? And we'll be using this information for our EMV momentarily. If you overbook 1 room and you have 0 cancellations, what do you need to do? You need to outsource that room. So by overbooking 1 room and having 0 cancellations, we need to send that person somewhere else. It costs at minimum $140. So we're out $140 if that happens. If we overbook 1 room and we have 2 cancellations, if we overbook 1 room, we can put that overbooking into one of those cancellations, but we still have 1 room that's open that nobody is in. So we're still out the money for that room, which would be $80. If we overbook 1 room and we have 3 cancellations, again, we can take one of our overbookings and put them in one of the rooms that people have canceled, but there's still 2 rooms that are open that no one is paying for that night, which would be 80 times 2, or we'd be out $160. If we overbook 2 rooms, overbooking 2 rooms with 0 cancellations means we need to outsource. It costs at minimum $140 to outsource. So 2 rooms need to be outsourced. So 140 times 2, we would be out $280. If we overbook 2 rooms and have 1 cancellation, we can take one of those overbookings and put it into that room where they canceled. That means we only need to outsource 1 room. So we're looking at $140 minimum that we're out. If we overbook 2 rooms and have 3 cancellations, we can put people in each one of those rooms. So overbooking 2 rooms, 3 cancellations, we have 1 empty room. That means we're out $80. overbooking 3 rooms. If we overbook 3 rooms and have 0 cancellations, that's 3 people that we need to find hotel rooms for at a minimum of $140 a piece. If I did my math correctly, that means we are out $420. Please check my math. If we overbook 3 rooms and have 1 cancellation, one of those overbookings can go into that 1 canceled room, so that means we only have to outsource 2 people. So that means we are out at least $280. And if we overbook 3 rooms and have 2 cancellations, that means that we are out 1 room, because we can take 2 of those overbookings and put them in the canceled room, and we just need to outsource 1 room, which we said was a minimum of $140. This right here is our decision matrix that we're going to use to figure out what is our best strategy. Expected monetary value for overbooking 0 rooms, 1 room, 2 rooms, or 3 rooms. So let's go onto a piece of paper here and figure out which would be best. So we're looking at an EMV for overbooking 0 rooms. Remember those probabilities that we had? This is where they come in. If we overbook 0 rooms and we have 0 cancellations, the probability was 0.5. So we're going to take 0.5 times how much money we'd be up or down. And remember, if we said we were at full capacity, that's where we want to be. We're going to zero ourselves out there and figure out what would be the best thing to do from there. So we would be up $0. We're going to add to that the probability times the outcome if we had 1 cancellation overbooking 0 rooms, and we said that was a -80. If we overbooked 0 rooms and there was 2 cancellations, the probability was a 0.15, and the consequence would be we would be out $160. And lastly, if there was 3 cancellations, the probability of that is 0.10, and we would be out $240. Now, if you're using a calculator that you're able to go through and do all this on, fine. I'm a step-by-step person, so I'm going to multiply each one of these points separately, and then I will add them up. So 0.5 times 0 is 0. 0.25 times a -80 is a -20. 0.15 times a -160, I got a -24, and a 0.10 times a -200 is a -24 also. So we're looking at now, what is the expected monetary value for overbooking 0 rooms? Well, I add these up. 0 plus a -20 plus a -24 plus a -24 is equal to a $68. Remember, this is talking about money, so we want to place a dollar sign on there and make sure you have the negative, or you have it in the parentheses accounting style, to show that it is a negative number. So by overbooking 0 rooms, our expected monetary value is we're going to be out $68. If we overbook 1 room, our expected monetary value for overbooking 1 room, we have, again, the 0.5 probability of 0 cancellations. But if there is 0 cancellations, we are out $140. It's a 0.25 probability of having 1 cancellation, which we would be out nothing. A 0.15 probability of having 2 cancellations, which we would be out $80, and a 0.10 probability of having 3 cancellations, we'd be out $160. Again, I'm going to take the time to do this step by step because that's how I do math. So 0.5 times -140 is a -70. 0.25 times 0 is 0. 0.15 times a -80 is a -12. Plus 0.10 times a -160 is a -16. I'm going to add all of this together. -70 plus 0 plus -12 plus -16, and I got a -$98. So our expected monetary value for overbooking one room is a -$98. So we'd be out $98. So looking at this so far, would you want to overbook 0 or 1 room? I would want to overbook 0 rooms because we're going to be losing less money that way. Let's take a look at our expected monetary value for overbooking 2 rooms. Again, we had that 0.5 probability of 0 cancellations, and if we overbooked 2 rooms, we said we were going to be out $280. So it's times a -280. The probability of 1 cancellation was a 0.25, and if that happens with overbooking 2 rooms, we'll be out $140. The probability of 2 cancellations was a 0.15, and if we overbooked 2 rooms, we wouldn't be out anything. The probability of 3 cancellations was a 0.10, and we would be out $80. Again, I'm going to do it step by step to do the math here. So 0.5 times 280, -280, excuse me, I got a -140. 0.25 times a -140, I got a -35, plus 0.15 times 0, I actually did it in my head and I got 0. 0.1 times a -80, I got a -8. If I added up my -140, -35, 0, and a -8, I got a -$183. So we've got our expected monetary values for overbooking 0 rooms, overbooking 1 room, and overbooking 2 rooms. Let's end this out with our expected monetary value for overbooking 3 rooms. If you overbook 3 rooms and you have 0 cancellations, remember again, it was a 0.5 probability, you're going to be out $420. If you overbook 3 rooms and you had 1 cancellation, a 0.25 probability, you're going to be out $280. If you overbooked 3 rooms and you had 2 cancellations, a 0.15 probability, you were out $140. And if you overbooked 3 rooms and you had 3 cancellations, a 0.10, you would be out nothing. Again, step by step, 0.5 times a -420, I have a -210, 0.25 times a -280, I got a -70, 0.15 times a -140, I got -21, and 0.10 times 0, do that in my head and I get a 0. So if I add up -210, -70, -21 plus 0, I got a -301. So looking at our expected monetary values for overbooking 0 rooms. You expected a negative 68. For overbooking 1 room, a negative 98. For overbooking 2 rooms, a negative 183. And for overbooking 3 rooms, a negative 301. What would you do and how would you write that? The answer or an explanation would be due to the lowest expected monetary value of negative $68. That's right. Even the best expected monetary value of negative $68, I would overbook 0 rooms. Expected monetary value, when they're negative numbers, you want to take the lowest one. That right there is a cost to you, and you want to take the least costly measure. Expected monetary value, when you're looking at all positives, you want the highest, the best possible value. This is the end of our decision matrix problem on expected monetary values.